layouts. Every app needs lots of layouts. They can be defined in XML or constructed at runtime, of course. Most of the time you define layouts in XML, then load them into your activities. I'm going to show you the three very basic layout types available in Android later. And of course you have all the typical layouts and widgets you know from other operating systems, buttons, checkboxes, text views, dialogues, whatever. That's how it looks in Android. The button and checkbox, radio button, on, off, then the star, which is, I think, specially to Android, a list box, and the progress dialog. Linear layout. Linear layout is very, very basic layout form. You just put everything in a single row, and then it wraps. Can be horizontal or vertical orientation. So describe how to wrap. You have two typical possible sizes for the child view. This is the wrap content, so it will automatically adjust to the size of its content, of a text entered or something, or to parent, then it will try to absorb all available space. Of course, you can work with pixels, define the width or height by pixels, but this will not work on all devices. Because screen sizes may vary. So it's best to go with one of those. Alignment is controlled by gravity attributes, so you can center things or place them at the right side or at the left side. Linear layout can create basic layouts very quickly. Very easy to understand. You just put everything into a single file and then this shown. But if you need a more complex layout, you will probably have to use nested layouts. So you want the button and a text box, and the button is always at the right side, and the text box is always at the left side. You will probably have to use more than one layout. So you get a pretty complex layout tree pretty easily if you're only working with linear layout. That's the source code of the typical linear layout, and that's how it looks on the right side. Horizontal orientation, just 4 views in different colors. Next is relative layout. Relative layout is my weapon of choice for almost everything. Relative layouts positions child views relative to each other or relative to the parent. So you can say, okay, I have a text box, and my button is at the right side of this text box. And the whole thing is centered in the middle of the parent view. This keeps the layout hierarchy tree pretty small, because now you can just throw in all the views you need and then say, okay, this goes there, this goes there, this goes there. Very easy. You have to keep in mind that the child can only refer to another view that is already defined, so you have to define them in order, like who did old Turbo Pascal programming. You define methods in order so you can refer to them later. Because of this order you have when defining the child views or relations between the views, adding views or switching visibility at runtime can be tricky. Because other views can not change their position to the view that is added at runtime. So you might tried to add a text box with some information at runtime, but the AUGE will not make space for it. So you have to keep that in mind. This is like a relative layer box. Very easy. No, you can't read it, right? So it's just says line, here and right, and then button goes there on the right side. Then the last one, I want to talk about table layout. Table layout is what everybody knows who's done web pages before. We all love table layout, don't we? Works more or less the same ugly way it does in HTML. You add first you add your rows, and then you add the child to those table rows. The order of the child determines in which column where it goes. So you have to count in memory when you place them to know where they go. Child can skip columns, of course, so you can say, okay, this is in the third column of the third row, so it's centered on the screen. And of course, the child view can stand more than one column. It's really just like table layouts in HTML. And of course, everybody is using it for fonts, as expected. Right, that's it to layouts.